just a quick little recap down memory lane. In the first week of our circle geometry sessions, we dealt with the facts or the theorems that deal with the circle in the center. So all of these drawings have a center point, and we have the line from the center perpendicular to the chord. We have the line from the center to the midpoint of the chord, and then probably the most important one, the angle at the center is twice the angle at the circumference. We also have that if we have a diameter, then basically you get a 90-degree angle subtended at the circumference, or angle in a semicircle. And then also if you have equal chords, they subtend equal angles both at the circumference, and they also subtend equal chords at the center as well. So, oh, hold on. Let me draw this in. So sure, if you have an equal chord, it subtends at the circumference, they'll be equal, but you also have it such that these two angles would also be equal. And in fact, both of these would be 2x because the angle at the center is double the angle at the circumference. Okay, so that was week one's theorem. Then last week, we dealt with cyclic quadrilaterals, and cyclic quads have all their corner points on the circumference of a circle. And the theorems we dealt with were that the exterior angle is equal to the interior opposite, or basically this one over here is equal to that. We dealt with the fact that opposite angles in a cyclic quad are not equal, but they are supplementary. They add up to 180. So we have that. And then the last lesson was mainly about this idea of angles in the same segment. So if you have a chord or an arc linking 2 points, and then you make an angle at the circumference, and you make another angle at the circumference, those two would be equal. And so what we had, that one and that one would be equal, but then also this one and this one would also be equal. And that's called angles in the same segment. Give me a score out of 10 for how well you think you know those facts. Give me a score out of 10 for how well you think you know those facts. Okay. Now, today's facts or theorems are all going to be based around the tangent theorems. I will talk more about them later in the lesson. I just want to do a bit of recapping of the previous lesson first. But there are 3 theorems that we deal with under tangents. The one is called the tan radius theorem. So it's about the relationship between a tangent line and the radius line, and the fact that they are 90 degrees always. So that's called the tan radius theorem. And then we also are going to look at what's called the tan chord theorem. And that's that if I have a tangent, and then the tangent makes basically the point of tangency has a chord that goes to somewhere else in the circle, then the angle subtended by that chord is equal to the angle between the tangent and the chord. And that's called the tan chord theorem. But I will talk a lot about that later in the lesson. And then the other tangent theorem says that if you've got a tangent from a common point, then the line from that common point, the sides are going to be equal. And that's basically going to form an isosceles triangle, that where AB is equal to AC. But it's easier if I show it to you in a visual animation, but that's called tangents from a common point. And so really the new stuff we're going to do today after the revision is going to be these theorems. So, but before we get there, let's start with this review question. And I want us to all zone in and think about what are some of the theorems that may be involved in this drawing. I want everyone to put something in the chat of some sort of theorem or fact that might be involved in this question. Circle central theorems. Yes, there's definitely going to be angle at the center, something to do with angle at the center, because I see that. Yeah. What are these funny looking railway tracks over here? What are they going to be? They're not radii. There are radii over here. So if you think about it's not that they aren't radii. You're quite right. If we look at this picture, these two are radii. But in fact, all this means is that the red one here is equal to the red one here, or we have isosceles triangles. Okay, so the other thing I want to point out that I've spotted is that what type of quadrilateral is, well, you could have, that could be a cyclic quad. What else? I think that's about it. There's a cyclic quad there as well. Okay, now what is the question? The question is express x. So let's find x. Express the angle x, which is like O1, in terms of y, which is down here. Now, in order for that to happen, I need to connect the y to the x somehow. So I want to give you a chance. What step, how can I get the y to be on the move? What would your first step be? Opposite sides equal angles. Yes, Sange, I think that would be a good one. I was thinking that this has to be y over here. So I can say that, that's too thick. I can say that PTR is y. And the reason it's y is angles opposite equal sides. Angles opposite equal sides. Okay. Now, I still have to connect the x and y together. What might my next step be? What might my next step be? Any ideas? Okay. So sum of angles in a triangle, yes, we could say that P2 is equal to 180 minus 2y, and that would be sum of angles in a triangle. So this would be that one. Now, what would P1 be then? What would this one over here be? So it wouldn't, well, it would be half of x, you're right. But oh, okay. Okay, you're onto something. I was going to connect them to x in the next step, but I was kind of staying in y land. If I had to write this in terms of y, what would I get for that green dot? So you know that this, right? You know that this one is 180 minus 2y. Give me a thumbs up if you understand why this has to be 2y, because that would just be angles on a straight line. Give me a thumbs up if you understand why 2y, or you could also say that's the exterior angle of the triangle. So the exterior angle P1 is equal to the sum of the interior opposites. Oh, Sange got there first. Well done, Sange. Okay, so we've got this is 2y. Now we have to connect these two over here. Now, we have already said that angle x is the big one. So we know that there's a relationship between the yellow one and the green one. Which of the two angles is bigger? The X or the 2y? Or the yellow or the green? Which one is bigger? So the X is the big one. So if I go and put an equal sign there, I need to say 2 times the small one is equal to X. And the reason is, let me just move some of my little things away. Angle at center. Oh, that's untidy. Let's try again. Angle at center equals twice angle at circumference. So what is X going to be in terms of Y now? What is X going to be in terms of Y now? It's going to have to be 4y. Yes. It's going to be 4y. So we've got X in terms of Y. X, this angle over here, is actually 4 of the Y's are down here. So that's the relationship. Now it says, if TQ, where is Q? Ooh, TQ is equal to TR. So this whole long thing here, this is equal to this. I'll make it 3 little stripes so we don't, oh, no. Let me try that again. So if I have 3 stripes there, so it's the whole long thing here, and it says to me, X is 120. If X is 120, actually, that's not so bad. If X is 120, what does Y have to be? If X is 120, what does Y have to be? So in terms of an actual value, calculate the actual value of Y. So 120, so X is 120 is equal to 4Y. What is the actual value of Y going to be? How could we move that 4 around? Yep. Indeed, what we're going to find is that 120 divided by 4 will equal Y. And so Y will be equal to 30. Okay, so we know that this is 30. We know this is 30. We know that this one must be 60 because it is double that. And we know this is 120. What is the size of R2? Now, where is R2? R2, you are hiding over here. What do we think the size of R2 is? Bearing in mind that we do know that this one over here and this one over here, these long ones, are equal. And we also know, what else do we know? No, we know those two are equal. So I guess what that means, interesting. Well, okay, I'll say this. Give me a thumbs up if you understand why this is 30 and this is 30. Because these are radii. So I've got 30 and I've got 30. Now I know, now how am I going to work out angle at center? Is there anything else I can use here? Let's have a look. At center, we know what that is going to be. Let me pull up the answers here and we can have a quick look. So you guys can see it's getting a bit messy here. Okay. So, and let me get rid of some of the stuff that's on the screen so you can see what we've done so far. And I'm just going to clear away some of the clutter so that it's easier to see. Then we're going to move on in a moment. I know this is taking a bit longer, but it's worth doing some harder questions with these type of things. So let's just get rid of some of the clutter. So we've established that this is true. We have also established that T is 30, and that's, now it says here, if that is 30, then TQR, give me a thumbs up if you realize why these two have to be 75. Basically, these bottom ones, I'll get rid of this because it's just too much information otherwise. What they're saying is this has to be this, and this has to be, this was 30, each of those has to be 75. Okay, now, we had worked out that this was 120, so angle at the center was 120. Now, O2 is going to be 240. Now, that's what I didn't pick up. So this one here would be 240. So let me write that in. 240. And then this one was 120. Oh, I'm running out of space. Okay, let me rather than just go from the answer. So what is R2? R2 is 15 because it is going to be 75 minus 30 minus 30. So that one must be 32. That must be 15. And R3 must be 30 because of the sum of angles in a triangle. Okay, so in summary, R2 is 15 degrees because I went 75 was the whole thing, and then there was 30 on each side. And then so the thing in between would be 15. And M would be 120. Well, because if that was 120, this would be 240. And so angles at the center are going to be twice the angle at the circumference. So that one over there is 120. All right. I think I probably spent enough time on that one. That was quite a tricky one, but I hope that gives you a sense of some of the detail that we can get into. So let us, before we get to our halftime break, let us go and look at the 3 tangent theorems that we are going to work with tonight. So I want to know, what do you notice about the point of tangency and its relationship with the center of a circle? What do you notice about the point of tangency and the tangent and the radius as I move things around there? Yeah, the tangent and the radius always seem to stay perpendicular. And so that is an important idea in terms of, it's called the tan radius theorem. And it's going to come up in the second half of today. But that fact can be very, very useful, that whenever you have a tangent to a circle, so it touches it in one point, it will be perpendicular to the radius. So that's the tan radius. And it applies at multiple places, right? So you can have a tangent over here, and then you can have a radius over here. Now, it doesn't look like it, but it will also still be 90. And you can see that in the shape. So that's called the tan radius, and we'll do some practice now. Then we've got the tangents from a common point. And let me make this a little bit bigger so you can see what is chopping. What do you notice about this? I'm going to have some fun. So I move the point, the common point, closer, but the points of tangencies aren't moving. But I can also move the points of tangency and the common point. What do you notice? Let's do it like this. What do you notice about the distance from the common point and the point of tangency? So what do you notice? I think I noticed that they always seem to be the same length. So it doesn't matter as long as the tangent points, and even if I move this around, actually can't move that like that. So actually, the distance from the common point to the point of the tangent is always going to form like an isosceles triangle. And then the last theorem to do with tangents in terms of the main theorems is sometimes called the Windsurfer theorem. And let's just have a look at what that looks like. So we have a tangent, and then we have a chord that connects to the tangent. And then that chord subtends an angle in the other segment. Now, the relationship is between the two red angles, but you could also have this happening from this side where you have a tangent. Now you have a chord with that tangent, and then that chord subtends an angle on the other side. Now watch this. I'm going to move the point of tangency. Notice the relationship between the red and the green angles. What do you notice about them? What do you notice about them? It seems to me like the green angle is always equal to the green one, and the red one is always equal to the red one. So the angle between the tangent and the chord is equal to the angle in the alternate segment. Okay. So let's see what this looks like in a question. So here is a multiple choice question to get us to the break. It says, the sketch EB, okay, the sketch EB shows a diameter and a tangent. The diameter is going to be the blue one, and because it's a diameter, it has to go through the center. So there's a center point, and now I have a tangent that goes past the circle and touches the circle at the point B. Then it says, if DBC is 72, so where's DBC? DBC. So this angle here is 72 degrees. Then what is D? So angle D, I'll make it green. Then what is the value of D plus EBD? Now, where's EBD? EBD is this one down here. So basically what they're saying is, what is the value of the green dot plus the blue dot? And you get to use any theorems or facts that you can to guess the right answer. Well, not guess, hopefully work out. So what answer do you think is correct? Is it A, B, C, or D? I'll give you a little hint. The theorem that is most useful here will be the tan chord theorem. So, sorry, not the tan chord theorem, the tan radius theorem. So the tangent and the radius will always have a 90-degree relationship. So what is the size of the blue angle? Indeed, Atlegang, you're right. So can we say D is 90 degrees? Oh, yes. So Atlegang has spotted this is a diameter, so this must be 90. So Atlegang said that's 90. Now all I need is, can someone help me find the blue angle? What is the blue angle going to be? What is the blue angle going to be? Stephen and Sange and Silikane, I agree with you. And the reason I agree with you is you know that angle EBC is 90 by the tan radius theorem. Therefore, the blue dot or angle EBD must just be 90 minus 72, which is 18. So then I've got 90 plus 18, which is 108. And the correct option would be B. All right, so that is an example of how we can use some of the tangent theorems together with the theorems that you've been learning about so far. But we've reached our halfway point, so it's important we take care of our brains and our bodies so that they are in tip-top shape for the second half of the lesson. So let us turn on our cameras and let us do some unwinding. Oh, I can feel my hamstrings are tight. Yo. So I think what I'm going to do is we're going to start with just hanging over like this and just let your hamstrings stretch out, or even just maybe stand on your tippy toes and let your calves stretch out. So just up on your tippy toes, see if you can stand up like that. And oh, I can definitely feel my legs are getting a bit tight. Okay, let's shake out our arms. Shake them out. Shake out this arm. Get nice and loose, nice and relaxed. Shake out your legs. Again, we're just trying to get our blood flow. Like it's, everyone's had a long day, and if our brains go into like nothing's important anymore mode, it's not going to remember the stuff that we wanted to. So we have to wake it up and put some work in. Let's do shoulder rolls. So roll like this. And let's roll forward. And then let's put arms out. Roll like this. And then roll backwards. Like that. Okay, then another shake. Just going to let someone in. So another shake, another shake. And then let us do some jumping jacks. So this is just to get our bodies awake, and jumping jacks are just like this. And we'll just do 10 today. So start in 3, 2, 1. Let's go. And there we go. And I have a nice riddle for you today in terms of the puzzle question. So here is the riddle for today. I add 5 to 9 and get 2. The answer is correct, but how? Who feels like they have some insight? -3. You sort of. I can give you a hint. Would you like a hint? This is a clever riddle. I like this one. The hint is, think of a circle. See if the hint helps you. Any ideas? I'm going to start making it even maybe too easy. Okay, final chance to get the riddle before I give it away. 14 is 2. I think Silicone has got this. So if you are at 9 o'clock and you add 5 to 9 o'clock, you get to 10, 11, 12, 1, 2. And so when you add 5 to 9, you get 2 when you're on a clock face. Yes, 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 yes. Well done, Siamtanda and Silikani. You are quite correct. Okay. Give me a score out of 10 about how your attention is now. We did a little brain break. You're not going to be 10 out of 10, but how are you feeling about your attention? If 0 is like, I have no attention, 10 is I have perfect, how are you feeling at the moment? Give me a little number in the chat. What is my attention score? 6.5, Sapang. That's not bad, Sapang. You can definitely work with that. Who else has an attention score they're willing to share? Okay, I know 7 is very good. Fantastic. You must have done your jumping jack, CM Tanda. Was that the key to your increased that's good. Okay. Let's do this. So you are given the following drawing. You can see visually that ABC is a tangent. You need to find me the value of A. Off you go. I'll be back in a second when I've got some water. See if you can find the value of A. Okay, so um, if we look at this, the most important thing is to realize this is 90. If you realize that that is 90, so let's write that. OBC is 90. Well, then 5A must equal 90 because, let me put the reasons here. This is going to be the tan radius theorem. And then this will be the sum of angles in a triangle. So then A is just going to be 90 divided by 5, which is 18. And I see in the chat there, students are agreeing with me, which is a good thing for everyone. And if that was 18, well, then 4 times 18 would be 72. So this angle over here would be 72. Okay, let's carry on moving. Question number 2, you need to find me, let's get rid of this one over here. You need to find me angle Y, angle X, and angle Z, sorry, and angle X. Which one would you go after first? I'm curious. Which one would you, so where you get 5A? Oh, let me just bring back the other question while you guys are working on number 2. So the place I got 5A, Sapang, was I took the 4A here and I added it to that A over there. And together that gave me 5A. So let me know if that helps, Sapang. What would I go after first? Would I go after the X, the Y, or the Z? The Z. Sange, what fact or theorem would you use to help you get the Z? What fact or theorem would you use to help you get the Z? So if we go with the tan chord theorem, so that would be a tangent, okay? That would be the chord, but the problem is the tan chord theorem would actually have to go to there. So for example, this one over here, oh, I did it wrong. Sorry, let me just take this off. So if you had that, then this would be equal to that one over there. So the problem is you actually, well, you can get it that way, but there's an easier way, and that's to focus on y first. So I want to point us to trying to find y. And the reason why is so much easier to find first, maybe someone can guess. Why is y so much easier? What fact have we not noticed yet? It's always coming up. Yep, they do love radii in this section. And it's always hiding there. It's like a little secret assassin that jumps in there. So what is y going to be? I think because these are radii, it's isosceles, you're going to go 180. Now, I'm not putting the reasons in because I'm sure you guys can do that yourself, but you're going to go 180 minus 50 divided by 2, because you take away the 50, but you need to divide it by 2. So you've used radii and the sum of angles in a triangle, and you should get 65 degrees. So now you know each of these y's is in fact 65. So let me write that in. So you know that each of these is 65. Now I want to get z. Who has ideas for z? What theorem might come in handy? Tan radius. Yep. Tan radius is super helpful. So let's just see. Here's the tangent. There's the point of tangency. There's the radius. So we kind of know that this would be 90. So what is the green dot going to be? Or what we would call z? What is z going to be? So z is just going to be 90 minus 65, which is 25. And the reason would be the tan radius theorem. Okay, so we're almost there. Last one for this question. What is the size of angle X going to be? What is the size of angle X going to be? Aha, Sangha, you are informed tonight. So it's what I think Sangha has realized is that this is 90, that's 50, this has to be 40, or X is 180 minus 90 minus 50. So X is 40, and the reason would be sum of angles in a triangle. And so X is in fact 40. All right, give me a score out of 10. How are you feeling about that question? That was a reasonably hard one. It wasn't easy. How are you feeling about your understanding of number 2? So the new theorem that we used in that one was the tan radius theorem. You can see the 90-degree angle that became so helpful, but we also used radii, and then we also used sum of angles in a triangle. So let's keep going. Let's do another one. You can always rewatch this on the recording as well if you feel like I'm going a little bit quick. So in this question, you have to find the value of E, you have to find 5E, and you have to find C. And there's clearly a tangent which is sitting over here. So find me some of those answers. And if there are any questions, as always, please do put your hand up. One of the lovely benefits of Maths Live is it's live, as the name says. And so you are free to ask whatever question you like, and I will do my best to answer, whether it be in the chat or even a live question. I do like hearing a student voice now and again. It makes me feel like I'm connected to all the humans out there. So who has some knowledge to give? What would I go for first? What's my first step? So the 5e, yep, I like the 5e. What would I combine it with? So I've got 5e, but there's no, oh, tan radius theorem. So we could say 5e plus e is equal to what? So if I go the yellow one plus the green one is going to be equal to what? I think it will be equal to, well, I suppose 6e, yes, but isn't this tan radius? So can't we say this is 90? Like this whole big thing is 90. So then if 5e plus e is 90, that actually means that 6e is 90. And now what is e going to be? Yeah, I'm just going to divide it by 6, and we get e is 15. So let's get rid of all this. We now know that this is 15, and this is 5 times 15, so that's 75. And that's good news because together that's 90. Now I have to find what c is. Now, what is lurking again in the drawing that can help us? Those lovely isosceles triangles that we get with radii. Yep. So what am I going to get for C? What am I going to get? Yep. So all you need to do is go 180 minus 75 minus 75. And then because essentially then you're going to get 30. And that would be C. And the reason would be sum of angles in a triangle and also radii. So you know this is 75 because of the radii, and then you know C is 30 because of the sum of angles in a triangle. Okay, so we're starting to get a feel for these new tangent theorems and how they can be used. Let's do this one over here. And in this one, you need to find F, and you also need to find G. So see if you can find what F is and what G, and what theorem that I showed earlier tonight would come up in this one. Tangents from a common point. Yep. So tangents from a common point, you have BC and you have BA, and these are tangents from a common point. And so that gives you a lovely, delicious isosceles triangle. So what is F then going to be? So we can say that F should just be 180 minus 80 divided by 2. And that would be because of the tangents from the common point give you AB equal to BC, and then the sum of angles in a triangle, and you should get 50. So F is 50, and this is also 50. Okay, well, what is G going to be? We now have to find a way to connect that triangle to the triangle on the other side. So what is, does the center theorem work? Unfortunately, it doesn't, because the angle at the center being twice the angle at the circumference would only really work like that. But something else has snuck in here. What's the relationship between the green and the blue? Okay, so you know that OCB is 90 degrees, and the reason for that is the tan radius theorem. But then what does that make this angle? Well, OCA has to be 40, because you know this whole thing is 90. So what is G then going to be? I think that if this is 40, G has to be 40 as well. And the reason for that is radii. So in fact, that would be 40, and this would be 40. Now, the question doesn't ask us to go further than this, but just to show you for fun, if I said to you, what is the size of the blue angle here? Could you work out what the size of the blue angle is? Oh, I saw a hand. Someone's hand was up there. Can I help? Just for fun, what is the size of the blue angle? So we know that this angle must be 100 to make 180. And this is an angle at the center, which means the one at the circumference has to be half the one at the center. Yeah. Okay, one more for tonight, and then we're calling it a night. So number 5. In number 5, you have to find I. You have to find H. And you also have to find K. Where would you start with these 3 variables? Would you start with K? Would you start with H? Would you start with I? So CM Tanda has indicated that K is where we should go first. Does anybody agree? Or would somebody like to go off to H or to I? I'll give you a moment to voice your opinion. I think you could go for H or for K. Either of them are fine, personally. But I want to see in the group, what do we think K is? Let's start with K then. I think most of us would say that that's 70 because of, so angle B is 70 because of angles opposite equal sides. So what does K have to be? Well, actually, that's quite easy because it's sum of angles in a triangle. So K must be 40. Yes, Sedekani, it is 40. Okay, so we've got K. Now, what is H going to be? Now, I'll give you a hint. This is a tangent. So that's a tangent. And this is a, oh, let me use a different color. This is a chord. And so this over here is going to be in the angle between the tangent and the chord. Can you remember what angle the green dot is going to go with? So the tan chord theorem is going to say that actually this one over here is the same as the H over here. So we're going to say H is 70 tan chord theorem. So this is going to be 70 as well. Okay, last one for tonight. What is the I down here going to be? And what theorem have I not noticed yet that could help me? So what we know is that tangents from a common point are equal in length. So this side here is equal in length to that one. So if that's the case, then this must be 70. And if that's 70 and that's 70, then this must be 40. So we'd first say BC is equal to DC, tangents from a common point. We then say BDC is 70, angles opposite equal sides. And then we'd say I is 40 because of the sum of angles in a triangle. Ladies and gentlemen, that is tonight's lesson. We have definitely got moving in the world of tangents and circle geometry. Let me know out of 10 how you found your understanding based on tonight's stuff. And then I also want to just share the link. We are doing exam boot camps. If you would like to sign up for the exam boot camps, then that is the link that you need to use. It's also on the website. And yeah, we really appreciate the support. You can share it with your parents. You can ask them. It just gives you an extra bit of preparation before exams. All right. Give me a score out of 10 before you finish off tonight, just so I know how you are feeling about the content and how I can, what speed I can start at in the next lesson. Okay. Now, the good news is you can re-watch this lesson.